Hello, and welcome back to the finale of the Genetics Lecture Series. My name is Drew Wico, and today we will be concluding our series with an example that will cover many of the things that we've talked about. Before we get to that material, we will briefly be going back over the concepts from Lecture 7. Lecture 7 involved how genetics is portrayed in pop culture. There are many different shows and movies that talk about genetics, but how accurate are they really? We talked about Jurassic Park, one of the most famous films that expanded off discovery in genetics during the 1990s. After looking at what the film proposed as possible, we broke down why bringing back the dinosaurs isn't as straightforward as they proposed. They primarily ignored key details such as DNA degrading over time, specifically how DNA degrades by 50% just over every 500 years. Along with this detail, they ignored the fact that fossilization protects the exoskeleton of mosquitoes, but not the soft tissue, which would include the blood. Based on this, the DNA in the blood that the mosquitoes had sucked up would have already decayed and wasn't fossilized. With all that is inaccurate with this movie, we discussed that the closest thing to what they proposed is possible, which is cloning. Dolly was the first successful mammalian cloning and helped the world of genetics learn a lot about what was feasible through cloning. It isn't the easiest thing to accomplish, but we've determined that at least cloning is possible. We also discussed the film Gattaca, which covered some key concepts like genetic discrimination, genetic determinism, and forensic genetics. Although the film proposed more extreme versions of most of these concepts, many of the concepts are issues present to this very day. Genetic discrimination is a key detail to consider, to the point that Congress has made laws against it. Genetic determinism is a more abstract concept, but it's commonly discussed with ethical considerations around genetics. Finally, forensic genetics was one of the more accurate concepts within the film, and we talked about how we accomplish this even in our modern-day science. Today, we will do a review through a lot of the material we've learned by going through an example. I've made an example of what a discovery of a genetic condition may be like for a family, and what a good process to go through is. Now, before we start, I am not claiming this is a completely perfect example, but it at least allows families to gain some insight to what it feels like to go through this process, and how what we learned about can truly be beneficial. The example that I've come up with is written out below. You can read along with me if you wish, but imagine that a couple, Tyler and Madison, are planning to have their first child. Madison has a brother, George, and George's son recently was diagnosed with PKU, or Phenylketonuria. After hearing this is a genetic disorder, Tyler and Madison are now worried about if their children may also have this genetic disorder. So we have our scenario. Where do we go from here? Well, the first logical thing to do is consider what the disorder is exactly. PKU isn't incredibly common, so learning a little bit about it first might be a good starting point, especially if there's already an understanding of being at risk, based on a relative's child having the disorder. The logical place to start for what PKU is, as well as many disorders is actually Google. Now, Google isn't a doctor, but it's going to tell you a lot of information. It at least gives you some understanding of what PKU is. Simply by reading the first result on Google, we learn that it's an inborn error in metabolism that can create issues ranging from intellectual disabilities, behavioral problems, mental disorders, and even seizures. This tells us that it's a genetic disorder that presents from birth. So it's important to know that a newborn might be affected by this disorder so we can help treat them as soon as possible. But with looking at PKU on Google, there's a lot of information to consider. Where can we go to get some more well-organized information? Luckily for us, the National Institutes of Health, or NIH, has created a site called the Genetics Home Reference. If you look for this in your Google search results, you will come to the page shown on the right of our slide here. This site is great because it gives you tons of information describing what PKU is. Not only does it do that, but it actually includes a graphic to help you understand the disorder, as well as provide key information like how it's inherited within a family, and even how frequent it is overall. Now that we know that PKU presents at birth and can cause lots of damage if it's not known, how do we know if a child will have it? That takes us back to our discussions on inheritance. The Genetics Home Reference tells us that PKU is an autosomal recessive genetic disorder. If we split these two words, we can figure out what that means exactly. An autosomal disorder is one that equally affects males and females. You might hear about disorders that are X or Y linked, which might skew whether it more heavily affects males and females. We also see this is a recessive disorder, which takes us back to lecture 2. Remember that for recessive disorders, both alleles must be the mutated or recessive variant for the individual to be affected. If somebody has one dominant and one recessive variant, they are called a carrier. On the right of the slide, we can see a graphic similar to the one that we had in lecture 2, where both parents are carriers. This is actually a slide from the genetics home reference that I just mentioned a moment ago. This means that out of the 4 possible outcomes of their children, there's a 1 in 4 chance that a child will get both mutant or recessive variants. There's a 2 in 4 chance that their child will be a carrier of the disorder, and a 1 in 4 chance that the child will not receive a mutant or recessive variant from either parent. We see this also mapped out in our Punnett square. A quick side note I just noticed while making this lecture is that the Punnett square here is different than the one that I put in lecture 2 for the same inheritance. In lecture 2, I showed the top left outcome showing as big D, little d, instead of the accurate 2 big Ds or dominant alleles that we see here. This version is the correct version of the Punnett square, so I apologize for my mistake for earlier in the lecture series. Hopefully it doesn't create any further confusion. Now that we know what the disorder is, how it's passed down in a family, and so on, where do we go from here? Well, since we know how it's passed down in the family, let's contextualize that information and apply it to Tyler and Madison through their pedigree. Here we see a very crude pedigree that I drew by hand. I wanted to show you that even I draw pedigrees or family trees by hand because it's sometimes easier than using complicated software. And you don't have to be an artist to do so and have the important information displayed. In this pedigree, we see our 3 generations, with generation 3 being the generation with both Tyler and Madison's child, as well as George's son. Note that since we know George's son is affected by PKU, he is colored in. We don't currently know the sex of Tyler and Madison's child, so they are represented by a diamond. And since we're focusing on the information for this child, the proband arrow is pointing to them. So, we have a pedigree built for the family. Now let's actually apply the details we have on PKU to this pedigree, and see what we can determine with our critical thinking hats on. On this slide, I've put our pedigree with important information about how PKU is inherited, the graphic depicting an autosomal recessive inheritance. Now, looking at this pedigree and this graphic, we can think about the important detail of how George's son is affected. Knowing it's autosomal recessive and the child receives 1 allele from each parent, if the son is affected, that means he has 2 recessive alleles. Where does he get each of those from? From each of his parents. This means that both George and his wife are carriers of PKU. They may or may not have known that they were carriers, but this is an important detail we can use to our benefit. If we know that they are both carriers, and now depicted as such based on the darkened circle within each of their shapes, what does this tell us in the context of Tyler and Madison? Well, if George is a carrier, he had to get his allele from one of his parents. There are 2 ways this could have happened. Since we know that neither parent is affected by PKU, given that they have not told their children such and they're not colored in the pedigree, this means that at least one of the parents is a carrier. It is also completely possible that both parents are carriers, since there's a 3 in 4 chance that their children are not affected by the disorder. This is shown by the 2 possible Punnett squares added to the slide here. Now, I've gone ahead and added a 3rd Punnett square, but why didn't I add that with the others? You might be thinking that this Punnett square could also represent George and Madison's parents, but why can't it? Remember that the topmost row and the leftmost column represent the 2 alleles that each parent has, or their genotype as we call it. The leftmost column shows 2 recessive alleles coming from the parent. Based on the fact that we are assuming neither parent has the disorder, and it's showing such in the pedigree, this would not be possible, since they would be showing the symptoms of PKU if they truly had 2 recessive alleles. So I'll go ahead and put a red X over this Punnett square. Looking at the 2 Punnett squares at the top, these are the possibilities that could lead to George and Madison's genotypes. So what are the chances that they are carriers for PKU? If we count the orange squares out of the total squares, we can determine that there is approximately a 50% chance that they're both carriers. If we can determine which of the Punnett squares accurately represents their parents, we can determine the true probability of Madison being a carrier. So, going through all of this information, we've determined a few things. First, we determined the inheritance pattern, meaning both alleles must be recessive for there to be a disorder. And remember that we got 1 allele randomly from each parent. If we want to figure out the possible outcomes for Tyler and Madison's child, for instance, we need to not only consider Madison's pedigree and genotype, but also Tyler's pedigree and genotype. We've also established that if George's child has PKU, this means that he and his wife are both carriers, since neither are affected yet passed it on to their son. Finally, we can successfully argue that one or both of Madison and George's parents are carriers, since George needed to obtain his recessive allele from one of them. Now, this seems like a lot of daunting information, but it at least provides direction on where to take this process. We can get a lot of information from learning about the disorder online and simply mapping out the family tree. So do that first and see what details you can put together. Based on what we've learned in this series, the first thing we know we need to do, is to consider Tyler's pedigree and genotype. By adding his information in, we can accurately calculate the risk that the child may get PKU. Now, if Tyler isn't a carrier for PKU, there may be a 0% chance of the child even getting PKU, so this is incredibly valuable information. Next, it may be equally valuable to contact a genetic counselor or other health professional to go through with genetic testing. In the event that you don't know your own health status, that information may be important in family planning. A genetic counselor or other health professional will be able to help you plan for any testing, walk you through the process, and ensure that you understand all the positives and negatives involved. Finally, in this scenario, it would be great to go ahead and start learning a bit more about PKU. Knowing facts such as those listed below are incredibly valuable. Sadly, there is no cure to eliminate the disorder, but the disorder can be easily managed through change of diet, so it doesn't cause any lasting effects. The best news of all is that when a child is born, almost all families undergo newborn screening to catch disorders like this before they can harm the child. This is so that even if a family doesn't know that they were carriers of the disorder and their child ends up being affected, they can still be provided treatment options and prevent any harm to the child. There are a number of disorders testing for this within newborn screening protocols, and they do vary state to state, but it's good to know that this does exist as a safety net. Overall, this is not a perfect thought process on what to do for every single disorder, but this at least explores some details that we learned about throughout the series that can enable families to have independence to it. I wanted to include some final notes that I feel are important to remember. First and foremost, we are still unaware of many causes of genetic disorders, so it isn't always as clear-cut as this example was. Something to remember is you know yourself and your child better than anybody. So if something is off, don't hesitate to bring it up to a healthcare professional. You may need to be a strong self-advocate at times, but professionals are prepared to listen and help. Another thing to remember is networks and communities such as this one are great, especially in the event of an unexpected diagnosis. Health information centers such as this partnership's family-to-family network are great. Also, don't be afraid to seek out other members of the community to ask questions and support one another. One detail that many people may get disheartened about is that there are usually not cures for these genetic disorders, but be aware that there may be significant improvements to quality of life for the individual affected. Research is continually being done to improve resources for all different disorders, so don't feel as if there is no hope at all. Finally, don't be afraid to ask questions. You may feel lost at first and not know how to ask a question or what the right question to ask is, but we all start from somewhere. Learning starts from many different points, and it takes time, but I promise you will learn. I want to thank you all for joining me for this lecture series. I've had a blast doing it overall, and I hope I was able to shed at least a little bit of light on the confusing world of genetics. Now, I do want to give one brief notion that I am one source, so do not be afraid to go seek other resources to learn more about genetics. But I guarantee we're all ready to help you, and we want you to learn about genetics. It's awesome. If you have any future questions, would like clarification on something we covered in this series, or even want to reach out to simply talk to somebody, my contact information is below. My time with VCU's Partnership for People with Disabilities and Center for Family Involvement is concluding soon, but I am surely glad to still help however I can. Thank you so much for listening, and I hope you enjoyed this final lecture.